welcome to our last section of Unit 9. So we're going to be doing some more factoring today. Today we're going to be factoring some special cases. So what I mean by special cases are either perfect squares or difference of squares. So by the end of today's lesson, hopefully you will know what those two terms mean. So what I mean by a perfect square is when I have something in parentheses, so let's say like x plus 5 squared. So another way you might see this is x plus 5 times x plus 5. This is an example of a perfect square because these two things are the same thing, and I can write them like this. So anytime we can write something in parentheses, x plus a number, or it could be like 3x plus 4 all squared. Anytime we can write a binomial in parentheses and square it, it's a perfect square. You also might see something that looks like this. So like 4x minus 2, let's change that to a 1. 4x minus 1, all squared. So again, this is just 4x minus 1 times 4x minus 1. Or x minus 3 times x minus 3. These are all examples of perfect squares. So the other thing you might see is difference of squares. So a difference of squares looks like this. So if we have like x squared minus 9. So remember in math when I say difference, difference means subtraction. So if I'm subtracting two things that are both something squared, so x squared is something squared, x squared is x squared, and I'm subtracting 9 from x squared, 9 is 3 squared. So those are two things that are squared being subtracted. So that's a difference of squares. So another example would be like 4x squared minus 25. So 4x squared is 2x times 2x. And then negative 25 is 5 squared. So the answer, if I was factoring this, it would look like this. So the first number is going to be the same thing. The second number is going to be the same thing, but with opposite signs. So 2x minus 5, 2x, I should say 5. Whoops. So these are important things because if you recognize difference of squares and perfect squares, factoring them is pretty easy. If you don't recognize them, especially the difference of squares, it's going to be really difficult for you to do the problems and you're going to miss out on a lot of points when you do assignments or tests. So make sure that you are able to recognize these two things. So if we look at example 1, so we got x squared minus 14x plus 49. So first thing we want to check, do these three terms, so whenever we factor, do these three terms have a common factor? Well, there's an imaginary 1 there. So 1, negative 14, 49, they do not have a common factor that's greater than 1. And they do not all have x in them. So the answer is no, I cannot factor them anymore. So I'm just going to have to factor them. So if you wanted to, you could use the box. You could put your a value, your c value, and your b value. So 1 times 1 is 1. 49 is 7 times 7. So 1 time. But notice that this is negative, so these are going to have to be negatives, because negative 7 times negative 7 is positive 49. When I multiply across, negative 7 plus negative 7 is negative 14. So our answers are in the box. So x minus 7, x minus 7. So notice, the reason this is a perfect square is because this number, 14, half of that is 7. So 14 divided by 2 is 7. And then 7 squared equals c is 49. So whenever that is the case, assuming that a is 1, it's going to be a perfect square. So if you can take half of b, so in this case it was negative 14. Half of negative 14 is negative 7. Negative 7 times negative 7 is 49. So it's a perfect square. So another way to write this, to fully factor it, would be x minus 7 squared. All right, so example 2. I'm going to go through the rest of these a little bit more quickly than that first one. So first thing we want to check for, we got two terms. Do they have any common factors? 1 and 100 do not have any common factors besides 1, no. And both terms do not have a variable, so the answer is no. So notice that we have a subtraction of two terms, so most likely that's going to be difference of squares. So what squared equals p squared? Just p. P times itself, or p times p, equals p squared. So these two first terms are going to be p. Since it's difference of squares, we always have a negative and a positive. It doesn't matter what order you do them in. What number squared equals 100, or what's the square root of 100? That would be 10. So that's all you have to do for difference of squares. Like I said, if you remember how to do this, it's really easy. If you don't remember how to do it, it's going to be almost impossible. Moving on to example 3. So first thing we want to check for, do these two terms have any common factors? So we got an x squared, a y squared, those are not common factors, but 104 do have some common factors. So if you have 4 quarters, that equals $1. So I know that 4 goes into 100, 4 also goes into 4. So the answer to our question is yes. So first thing I'm going to do is factor out a 4 from each term. So if I factor out 4 from 100, 100 divided by 4 is 25. Still have that x squared. Minus 4 divided by 4 is 1, so just 1y squared or just y squared. So now I'm going to look at what's inside of the parentheses and try to factor that. So I look at the first term. Since I am subtracting, and I have two terms here inside of the parentheses, I'm going to assume that it's difference of squares. So if I'm looking for difference of squares, what squared would equal 25? Or what's the square root of 25? That's 5. What's the square root of x squared? X. So I know 5x is going to be the first term in each set of parentheses, and then I have a minus and a plus. So what squared equals y squared, or what times itself equals y squared? So that'd be y. So our answer to example 3 is 4 times the quantity of 5x minus y times the quantity of 5x plus y. So that is difference of squares. So on the next page, we need to factor 4x squared plus 36x plus 81. So do those things have any common factors? Well, 4, the only thing that goes into 4 is 2, or 4. And that's not going to go into 81, so the answer is no. They do not all have a variable in it. So I'm going to assume this is a perfect square. So what two numbers can I multiply together to equal 4x squared? What two are the same numbers? So if I multiply 2x times 2x, I get 4x squared. Both signs are plus, so these are both going to be plus. What number squared is 81, or what's the square root of 81? That would be 9. So 2x plus 9, 2x plus 9, actually, we should write it like this. 2x plus 9 squared should be our answer. So if you wanted to check if this was correct, do the FOIL method and see if you're correct. So 2x times 2x is 4x squared. The outside is 2x times 9, so that's 18x. Inside, 9 times 2x is 18x. And then the last 9 times 9 is 81. So if you combine like terms, the green and the blue, that would be 36x. So it equals our original problem, so it is correct. So 2x plus 9, all squared, is our correct answer. So in example 5, again, I have two terms here being separated by a minus sign, so that's a difference. So I'm going to look if these two terms are something squared. So what could I multiply times itself to equal x to the 4th? Well, if I multiply x squared times x squared, that'll equal x to the 4th. So remember, if it's a difference of squares, we'll always have a plus and a minus, or a minus and a plus. Doesn't matter the order. Oh, and we checked. These do not have anything in common, so no. So even though I just forgot to do that, don't forget to do that. Always check to see if they have any common factors. And then what two numbers can you multiply to equal 25? Or what number can you multiply by itself to equal 25? That would be 5. We have y to the 6th, so y to the 3rd times y to the 3rd equals y to the 6th. So notice that these two y to the 3rds are the same thing. So if I multiply 5y to the 3rd times 5y to the 3rd, that would equal 25y to the 6th. So that would be our answer. In example 6, going to check to see if they have any common factors. They don't. This number is 1, so I know I cannot factor them anymore. So is there anything that I can multiply by itself to equal 1? So 1 times 1 is 1. 2 times 2 is 4. X times x is x squared, so 2x, and then 1 plus 2x. So basically, when we have a difference of squares, what we're looking for, if we have two terms that are being separated by a subtraction sign, can we take the square root of the first term and the square root of the second term? If we can, difference of squares, and you write the first square root in the first slot, second square root in the second slot, separated by a minus and a plus. Our last example. First thing I'm going to do is check to see if all these have a common factor. It doesn't look like it at first, but they actually do. So I know that 3 goes into all 3 of these terms. So 3 goes into 6 2 times. Still have the x squared. 3 goes into 21 7 times. 3 goes into 15 5 times. So now I'm going to see if I can factor what's inside of here. And I forgot to circle all these things previously. So this was a perfect square. Difference of squares. Difference of squares. Whoops. Perfect square. Example 5 was difference of squares. 6 was difference of squares, and then back to 7. So can we take the square root of 2, first of all, and get a whole number? No, we cannot. Can we take the square root of 5 and get a whole number? No, we can't. So it's not going to be a perfect square trinomial. It's definitely not difference of squares because we have, first of all, we have 3 terms. For difference of squares, we only can have 2, and there would have to be a minus sign. So it can't be difference of squares. So we're just going to have to factor it the old-fashioned way. So we can use the box or whatever method you prefer. So A is 2, B is 7, C is 5. So two numbers that multiplied equal 2 are 2 and 1. Two numbers that multiplied equal 5 are 1 and 5. When I multiply across, 2 times 1 is 2. 1 times 5 is 5. So 5 plus 2 is 7. So I still have a 3 on the outside of these parentheses here. So I take the top left, multiply that times x, add its diagonal, so 2x plus 5. Take the bottom left, multiply times x, add its diagonal, so x plus 1. And that is your answer. And that is it for the notes.